Hello Internet! Today we have this weird looking graphics card from Nvidia that comes with this pigtail. I'm guessing it's an RTX A6000, I don't know. Customer stated something that wasn't very helpful, so let's take this thing apart and see what's going on. This looks like a very special graphics card and it requires an unusual set of screwdrivers. Lucky me, I have that available, so let's continue. This card came with a #1 label on it. For some reasons, customer knew this was going to be my #1 A6000 ever, so not sure how he knew. Anyway, let's continue with the assembly and see if we can figure out how to crack it open without cracking it. It looks like the shroud and the heatsink are separate units and the shroud came out by itself, but the wire was still screwed to the shroud. Very strange solution, but what do I know? I'm not here to design anything. I'm here to fix it, so let's continue. After fighting with it for a while, the back plate finally got unstuck from the board, revealing another strange design choice, where fan is connected to the back of the board, so that when you attempt to service your GPU, you're very likely to rip the connector off the board. Great job, Nvidia. Anyway, the way this connector works is that you slide the cover out of the way and then lift the connector straight up like that. Very strange, but who cares? Judging by the looks of it, the card is not much different from a 3080 Ti Founders Edition, with the exception of a ton more memory. My guess is that this is some kind of a mining card, or something used in a 3D production maybe? I don't know, I don't care. All I care about it is what's wrong with it, and if I can fix it, and if I can make a customer happy and get paid. So let's get on with that. Thermal interface under the core looks and feels dry, indicating that it was overdue for service, and no surprise. The construction of this card makes service nearly impossible for a user. My guess is that's why no one bothered. In any case, let's take some basic measurements and see if we find anything wrong. Kiloohms on 12, kiloohms on 3.3, 1.8 with 1K, PEX with 4.5 ohms, memory 10 ohms. This I believe is a 5V with several kiloohms. This inductor here has several kiloohms as well, and this one is the same. Let's check the data lines. First pair looks the same. On the back, different reading but also about the same. Clock reference about the same, and PEX reset looks okay. Found another coil here, don't know what it is yet, but it has several kiloohms on it, so I think we're good. Okay, not finding any short circuits, we can power the board and see that for some reasons we have a short somewhere. And then I thought, what if I use the provided pigtail adapter and see if it makes any difference? Interesting. My question to Nvidia engineers now is, did you design this connector to accept standard PCIe cables on purpose? Imagine you don't have this adapter. Plugging in a standard PCI cable will short 12V to ground, making you think that you have a dead GPU. I guess it's always a good way to make people buy more GPUs, assuming a perfectly working one is dead. Jerks. Anyway, 1.8 amp looks reasonably within the range of a live in kicking, so let's check for voltages. 1.8 check. That means we have 5. This one here is 12. This one here is 12. PEX check. Memory check. Core check. And before we plug it in, let's make sure that all cores are active. Sometimes this can prevent card from being detected. Nothing criminal here, so let's go ahead, plug it in and see if we get a picture. And maybe we can run a memory test while we're at it. Looks like some artifacts are showing up already. That's great. And now let's take a look at the primary report and see what we've got. Both MATs and the NVMT had confirmed that we have a problem with an A0, so I will remove the thermal pads so that we can get an access to the chip. This is the chip that I'm interested in, and now you wonder, could it be the one on the back? I have no idea how to tell exactly which one it is, so I will rely on my experience and just replace the one that's at the front. Something tells me this is the one. Okay, the chip is replaced. We want to make sure that we didn't create any short circuits on 1.8 in memory rails. Looks about the same as before, so let's power it on and run the memory test once again. Whoopsie, looks like I booted the memory utility into UEFI instead of a legacy, so that's why it looks like that. I'm going to restart the computer and try again. That looks more familiar, and we even got a pass. Great. Once I boot it into Windows, card was recognized as A6000, which is great, so I will kick it in the nuts with the firm mark, just for a second to make sure that it does not crash. Then I will gently brush it with the valley to make sure it's clear, and then go back on the table for the assembly. Followed by more stress tests, benchmarks, etc. All seem to work. As of today, card was sent back to its rightful owner, who I hope would update us with the status in the comment section. And until then, this is all I have for you today. Thank you for watching and have a blessed day. Goodbye. Oh, and I almost forgot. If you have a card for repair, I have a contact info in the description. Bye now.